Okay, yesterday we left off on number 14 and 6.3. So considering we need a little more time to get done before we're going to do our quiz will be postponed for another day. Tomorrow will be review for quiz and any more questions that we might have in these packets. It says to graph each quadrilateral with the given vertices and determine the whether the figure is a parallelogram. And it's telling us that we have to do it by distance and slope. If you're going to do distance and slope, we're going to try to prove that one pair of sides is both parallel and congruent. It could be this left and right, or it could be the top and the bottom. You just got to pick a pair. So -3, 2, I'm plotting my points. Okay, so there are my points plotted, and then I'll connect them to form the parallelogram. If it is one, we're going to prove it. And then I need us to pick a pair of sides to prove that it's a parallelogram or not. So I'm going to choose AB and DC. And I just did it because that's the first one I see. You could have chosen AD and BC. All right, so now what I need to do is find the slope, which is the fastest way to do it, is do the slopes first, and then the distance. So the slope of side AB, we can go up 2, right 2 to get from A to B. So that's a slope of 2/2. You can reduce that to 1. Then I would find the distance, which is the length of the segment. You can use the slope numbers, the 2 and the 2, and do the square root of 2 squared plus 2 squared. That would give you the square root of 8. So I have found the length and the slope of the side AB. Next, I'm going to go find the slope and length of side DC and see how it compares. The slope is 2/2. So clearly the slopes are the same. And the distance would be the same because you take the slope numbers, 2 and 2, 2 squared plus 2 squared, the change in the y's and the change in the x's, and you do 4 plus 4 and get the square root of 8. We have just proven that it's a parallelogram because one pair of sides, one pair of opposite sides are parallel and congruent. So that means we have a parallelogram. Okay, so this is what you have to show. It doesn't take that long to find those answers. And then you give a justification. All right, because the slopes are the same and the lengths are the same of those segments, we've got a parallelogram. Okay? Anybody still need this? All right, so now 15. Please go ahead and plot your points. We're going to be doing the midpoint formula. That means we are going to see what the midpoint of the diagonals. And if it is the same for both figures, for both segments, then we will have a parallelogram. If not, it's not a parallelogram. Oh boy, I'm pretty much seeing quickly that this thing does not look like a parallelogram. At least not to me. Do you think so? All right, if we're going to do midpoint, we have to find the distance across from one diagonal and the other diagonal and see if they have the same midpoint. Did I plot those all right? I think so. Is that what yours looks like? Okay, this was point I up here. So I'm going to have to find the midpoint of IG and the midpoint of the other diagonal, which is HF. Midpoints are found by adding the x's for each point and dividing by 2. Add the y's, divide by 2. So IG, 1 and -1 are the x values. 1 plus -1 divided by 2. And the y values are 2 and 4. So 2 plus 4 divided by 2. 0 plus -1 is 0. I said the answer instead of the numbers. 1 plus -1 is 0. 2 plus 4 is 6. If I divide, 0 divided by 2 is 0, and 6 divided by 2 is 3. So I found the midpoint of IG to be the point 0.03, which is right there. Well, that's not even on the next segment, but I'm going to go ahead and verify what the midpoint is of HF. So I take the points for H and F. The x's are 3 and -3. I add those and divide by 2. I add the y's, 3 and 1, and I divide by 2. So when I add 3 and -3, I get 0. So I do get 0 for the first part of the midpoint, but the second part is 4 divided by 2, which is 2. So the midpoint of HF is actually right there. They do not have the same midpoint. Midpoints are not the same. So that means the diagonals don't bisect each other. And this is not a parallelogram then. I mean, this is a very big explanation. The midpoints are not the same, so the diagonals don't bisect each other, and it's not a parallelogram. Now, I know you probably won't write quite that much if you're doing it on the quiz, but you would have to say something about the midpoints are not equal, so it's not a parallelogram. It has to have the same midpoint for the diagonals. Okay, numbers. Oh, now that was the end of what was supposed to be all the examples. And then you were going to go to the book pages, which are next. That second period. Let's see, I'm trying to find your class here first. Oh, well. I'll just open one up and give some hints. Now, you can tell me if you already see some problems you know you'd like me to help with, and then I'll look at problems from 6.2 as well. 6.2, we have some examples we need to finish as well. All right, so you're going to be using all these reasons here. You're going to have those in front of you, and these are all the ways to prove that you have, if you have a parallelogram or not. Reminder of what they are: one pair of sides both parallel and congruent, opposite sides congruent, two pairs of opposite sides congruent, two pairs of opposite angles congruent, consecutive supplementary angles, and diagonals bisect each other. Okay, now these are probably not ones that you need so much help with. All you would need to know is that opposite sides are congruent. That's what you're going to use to do the algebra here. So this one could be set up for finding x like that, and 2y equals y plus 19 would be setting up to find y. I'm not going to solve all these for you. I'm just showing you how you're going to set them up. Okay, so in this one you do the 4x minus 3 equals 3x. I'm not sure how you want to approach that as far as do you want to subtract 4x from both sides. Don't forget to do that. 2y minus 11 equals y plus 3. Those would be the equations you would use for 1 and 2. So I'm not going to sit here and do those. I'm going to let you, because I'm giving you the time. Now, to set up these two, you would use opposite angles are congruent in number 3. And number 4, opposite sides are congruent. If you want to write down those and then finish solving them. Okay, 5 and 6, very similar. You're going to use opposite angles, are congruent. And the other equation, 7x minus 11 equals 5x plus 29. All right, I think that's enough. These are all just a bunch of similar questions for me to, so let's find something that you might actually want some help with, or what I think we should talk about. I pulled one up that already had answers on it, so that was kind of not the best choice. I'll erase here, and then we'll talk about these. All right, so let's look at 9 through, well, 14, I think it is. If you were to look at this kind of question, you will definitely have to be able to answer. If you saw this diagram, would you say what would you say about it? Is it a parallelogram or not? Does it have to be? Is it one of the properties in the list? And that's yes. It is the last one. It's because if the diagonals bisect each other, it's a parallelogram. Then you get a parallelogram. You can use that abbreviation symbol. Can you justify this as a parallelogram in number 10? And why? Please look at these. How would you tell? Same what? Those are angles. Okay, so since opposite angles are congruent, then we've got a parallelogram. So this is a yes. If two opposite angles are congruent, then you have a parallelogram. I'm not making you write if it's a quad with two pairs of opposite sides, opposite angles congruent, then it's a parallelogram. I'm trying to shorten it up. What about 11? Is there justification for a parallelogram? Does this look like one of the situations I gave you in your box? It's the first one, yep. Okay, so that's yes, and how you describe it? If one pair, opposite sides, parallel and congruent, then you have a parallelogram. You are going to have to provide the reason. Right? Okay? What about 12? Does that look like anything? What's it giving you? All it shows is one pair of parallel sides. Does that mean it has to be a parallelogram? And this would be no, not enough info. Okay, so you're going to have to know if it's enough or not. That is info. 13 I have starred. That's the one I told you to draw in up at the top of the box on your 6.3 ISN. This is a pair of parallel sides and a different pair of congruent sides. This one is no. Okay. It needs to be, I guess a way to describe that, needs to be the same pair of sides parallel and congruent. Okay, and 14, yes or no? Okay, am I going too fast? 14 is a yes or no. Is that enough information to prove it's a parallelogram? Yes, it is, because if two pair opposite sides are parallel or are congruent, then you have a parallelogram. That's a property of parallelograms. Okay, you want to tell me if you want me to do any particular problem that's coming up. If you want to pick something, if you think you don't know how to do it, you may ask. But I think those are left for you. I really think you should practice those 15, 16, 17, etc. All right, in a couple minutes, I'd like to answer questions after you, or if you start to find that you have something else you would like me to answer on here, I will. But then I'm going to go on to doing some problems in 6-2. So I'm going to pause. We did not get past number 9 in our 6.2 packet. So I want to go back and revisit that. Find the value of each variable. The hint here comes from this little triangle over here on the left. You see that congruent angles marks? What kind of triangle does that make that triangle? Based on stuff we learned last semester. What type of triangle has base angles that are equal? Yep, isosceles. Okay, so if it's isosceles and that's a 90, a right isosceles, then I go 180 minus 90 and I get 90. And that's to be shared between those two equal angles. So I divide that by 2. And these angles are 45 degrees. Which makes this 45. And so 3x equals 45 would solve it for x. And 3x is 45, and you divide by 3, you get x is 15. Okay, now alternate interior angles are congruent if this is a parallelogram, so that means this is a right angle also, like that one up here. This side would be congruent to this side and this side. Now, they've told me 2y here. We have not studied special right triangles yet. I can show you how to get 2y solved, because this would be 12 and this would be 12, and that's a right triangle. So I could use Pythagorean theorem, but I would not expect you to be doing that at this time. And let me explain why. Solving, I would not give this as a quiz question, but this would be the hypotenuse of that triangle. And so 12 squared plus 12 squared would actually equal the hypotenuse 2y squared. 12 squared plus 12 squared, you could type on your calculator, 144 plus 144 is 288. And when you square 2y, you have to square both of them. That means 2y times 2y, which is 4y to the second. 4y squared. Then you can divide by 4. And if you divide by 4 on both sides, you get 72. So then you could take the square root. I don't know why that went to that shape, but there, let me make it bigger. Take the square roots, it'd be the square root of 72. And as I said, I actually crossed that off in some classes. Okay, I'm not going to ask you to do that on the quiz or test. Not at this point. We will be getting into special right triangles, and then I'll teach you how to get that answer in a different way. All right, so on number 11, though, very doable. If this is congruent to this, then these two are congruent to them. So 2y is equal to 28, and 4x is also equal to 28. All right, so you should get y is 14 and x is 7. All right, number 12. Again, we haven't done special right triangles, so I'm going to have you cross off y, and then say we can do 3x equals 10, because the diagonals bisect each other. And you can divide 10 by 3, which is 3.3 repeating, or 3 1/3. Ignore this stuff because we're not doing it yet. Number 13, you don't have these things, do you? Do you have the same number 13? Yeah, do you have this, though? No, oh, there's a blank. I took it off. That's because I didn't want you to have it anymore. All right. Okay, so let's look at 14 and 15. I'm glad I took it off. I should have. We've got 29 degrees here, and alternate interior angles are congruent, so x is 29. And I'll highlight that in case you're not seeing where I'm getting that from. This is our alternate interior angle, backwards z. Then you can go and find this angle. Angle z is real easy to find because that's a linear pair. So this would be 29. Okay, and then you can use the fact that the triangle's angles add up to 180 up here. You can do 180 minus 78 minus 29. And that's 180 minus 107. So that should be y is 73. And z, 180 minus 78 would give me z is 102. All right, so 15, we should use our alternate interior angles. Again, going this way, x would be, are these the right numbers for your paper? 31, okay. Yeah, I thought so. Somebody told me that I had to change these. I must have pulled up an old Smart notebook. You have a 43 up here? And what's this one? Weird. Okay, so that would be x is 43. Y would be 32. And z has to be 105. Opposite angles are congruent. Okay. 16. We've got opposite angles are congruent. So x would be right away 73. And then look over here. Maybe you're wondering, what's y doing there? Look, what is y? How big is y? Those are alternate interiors. Okay, 73. Now, z, you can find two different ways. These angles add up to 180. They are supplementary consecutive interiors. Okay, so consecutive angles are supplementary. We're going to subtract 73. And z is going to be 107. Okay, we feel okay about that? All right, 17. Why is it impossible for this figure to be a parallelogram? Hint. It's not a parallelogram because, right, opposite sides are not congruent. Only one pair is. Number 18. Why is this not a parallelogram? Yeah, the angles need to match across from each other. Opposite angles are not congruent. And there's another reason. Consecutive angles aren't supplementary. They only are going this way. Those are supplementary, but going this way, they're not. One answer is sufficient, though. Okay, so if we were to find this, it says find the intersection of the diagonals. That means we want to find the midpoint of diagonals. Let's graph this. 3, 6. 5, 8. Oh, kind of put that in the way. 3, -2. 1, -4. That's going to be a very skinny shape, isn't it? Okay, so what we're testing for is if the diagonals have the same midpoint. And one of the diagonals would be DB, and the other would be AC. So they've just written down for us to find the midpoint of AC. So you take your x's and add them. 3 plus 3 divided by 2. Take the y's and add them. 6 plus negative 2 divided by 2, and then I'll simplify those. That's 6 plus negative 2. It looks like I wrote just plus. Okay, that gives me 4 divided by 2 and 6 divided by 2. Well, 6 divided by 2 first, which would be 3. Oh my. My pen is just having a delayed reaction. Oh, there we go. 3, and then 4 divided by 2 is 2. So now we want to see if we get the same midpoint by doing BD. BD has an x values of 5 and 1. 5 plus 1 divided by 2 is going to be 3. 6 divided by 2 is 3. And the y's are 8 and negative 4. 8 plus negative 4 divided by 2 would be 4 divided by 2, which is 2. So since we have the same midpoint for both diagonals, then it's a parallelogram. Okay, diagonals should meet at the same midpoint. Let's try one more here. 20. Got negative 4, 3, 2, 3, negative 1, negative 2, and negative 7, negative 2. What's it say to do? It says find the coordinates of the intersection of the diagonals, it should say. All right, we want to find the midpoint of AC and the midpoint of DB. AC, negative 4 plus negative 1 divided by 2. And for the y part, 3 and negative 2. 3 plus negative 2 divided by 2. It's going to be negative 5 divided by 2 and 1 divided by 2. You can just leave it, negative 5 halves and 1 half if you like. And then I need the midpoint of DB. D and B, x's are 2 and negative 7. 2 plus negative 7 divided by 2. Looks like that's going to give me negative 5 over 2. And the y's, 3 and negative 2. Add them. 3 plus negative 2 divided by 2 would be 1 half. So we got the same midpoint. And that should occur because it says it was a parallelogram. Remember, if we're going into that proving it's a parallelogram, this needs to be true for it to be a parallelogram. All right, so the homework was after that. Does anybody already know one they want to ask me in the last few minutes of class? We can still ask some more questions. You might be able to tomorrow. I'm going to stop recording. But we will be reviewing for quiz tomorrow.